Model number 1. Okay, there will be a DC circuit and fundamentals of AC circuit. Okay, with respect to the DC circuit, what I discussed about Ohm's law and its limitation. That is, current flowing through the conductor is directly proportional to the applied voltage and inversely proportional to the resistance, provided temperature remains constant. That is, V is equal to I into R. Then Kirchhoff's laws. There will be a Kirchhoff's current law, Kirchhoff's voltage law. Algebraic sum of currents meeting at a junction is always equal to 0. That you have to remember. Then with respect to the Kirchhoff's voltage law, algebraic sum of voltage drops and the EMF sources by taking proper sign is equal to 0. That is with respect to the what? KVL. Then analysis of the DC circuit. In case of DC circuit, only the pure resistance will be present. There will be absence of inductance as well as the capacitance. So that for the analysis of the DC circuit, for series circuit, if the resistances are connected in series, then the effective resistance is equal to sum of the individual resistance values. If it is connected in parallel, then the reciprocal of effective resistance is equal to the sum of reciprocal of the individual resistances are connected in parallel. Then current dividing rule, whenever the two resistances are connected in parallel, how to find the I1, how to find the I2. Okay, it means that total branch current multiplied by other branch resistance to that of the total resistance of the parallel combination. That is with respect to the current divide rule. Okay, then power and energy. Okay, the power is the what? The product of voltage and current in case of the DC circuit. Energy is what? Power into time. Power is measured in watt, energy is measured in watt second, watt hour or kilowatt hour. Watt second is the smallest unit, but we are concentrating on the largest unit, kWh, kilowatt hour. P is equal to V into I, P is equal to I square into R, P is equal to V square by R. Okay, next topic with respect to the maximum power transfer theorem. Now I will discuss that. Okay, then I have discussed with respect to the problems. Loop current evaluation, that is by providing a network in that you need to find the branch currents with respect to that of particular branch. Then branch current and the power, they will provide the two resistance in parallel, one resistance in series, then they can expecting the current evaluation and the power evaluation. That's also I carried. Then problems based on the series parallel combination to find the current. Then current through emitter. Okay, network they will give. In that network, they will connect a one emitter. For that current, what is the current which is flow through that emitter? They will ask you to find. Then voltage between the terminal X and Y. They will provide one network. In that network, you are going to make the evaluation of the voltage drop or the potential drop which is to be happen with respect to that of terminals X and Y. Some cases, they can be represented A and B also, P and Q also, based on the question paper set. Then maximum power transfer theorem problems. Okay, that is also we discuss. Then with respect to the AC fundamental, in yesterday 2 classes I have discussed with respect to this. That is the generation of the sinusoidal voltage, which will be get generated based on the Faraday's law. Flux linking with respect to the conductor, if it changes, then obviously which will causes the induced EMF. That itself is called as the dynamically induced EMF. That is alternating in nature. That's the reason that will be produced in the form of the sinusoidal voltage. Then derivation with respect to the alternating component. There will be a average current. Average current is nothing but whatever the sources, if you need the replacement of AC by DC, it has to cause the same amount of charge to be transferred to the circuit element. That is called as average quantity. It might be a voltage, it might be a current. If it is a current, I average is equal to 0.637 into Im. If it is a voltage, 0.637 into Vm. Vm is what? Maximum value. Im is what? The maximum value of the current and the voltage. Then RMS value is what? Whenever a circuit is connected with a resistance, if there will be a replacement of AC source or the DC source, because of that replacement, it has to produce the same amount of heat by the replacement of AC, by the replacement of DC. Whatever the magnitude of current which it is flowing is itself is called as RMS value. Okay, that RMS value might be with respect to the current, the RMS value with respect to the voltage. That is IRMS is equal to 0.707 into IM. Then VRMS is equal to what? 0.707 into VM. This is not IM, this is VM. Okay, this is with respect to the what? The average value and the RMS value. Okay, this derivation you can practice. That is also be important for the examination point of view. Then KF is what? Form factor. The ratio of RMS value to the average value is itself is called as the form factor. It might be with respect to the voltage, it might be with respect to the current. If you are considering for the current, IRMS to the I average. If you are considering with respect to the voltage, VRMS to the V average. That you have to remember. Okay, because this is also one of the parameter we are going to consider for the problem evaluation point of view. Then KP is what? Peak factor. That is the ratio of maximum value to that of RMS value. If it is a voltage, VM by VRMS. If it is a current, IM by IRMS. Okay, whatever the value it is there for the KF and the KP, it is a constant. KF value is what? 1.11. KP value is what? 1.414. Okay, that is the what? The values corresponds to that of form factor and the peak factor. Then phasor representation. The phasor representations can be done with respect to that of in phase quantities and the out of phase quantity. If the minimum values and the maximum values will occur at the same instant for the two different quantities, might be with respect to the voltage, might be with respect to the current, then which it is said to be what? In phase. If the quantities, whatever which has happened for the minimum value, if it is causes the maximum, then which it is said to be out of phase. It might be in the form of lead, it might be in the form of lag. Okay, as you can discuss, that is in case of pure inductance and the capacitance. Okay, with respect to the pure resistance value, what happens? The current and voltages are in phase. The current and voltages are in phase. Okay, if it is a pure resistance, if those are in phase, what is the pi value? Pi value is equal to 0. What is the cos pi value? It is 1. What is the amount of power which is consumed by the pure resistance? It is the product of RMS value of the current and the RMS value of the voltage. That is V into I. Then with respect to the pure inductance, current will lag the voltage by an angle 90 degree. But if pi is 90 degree, cos pi is equal to cos 90. Cos 90 value is what? 0. What is the power equation in case of AC circuit? P is equal to VI into cos pi. If cos pi is 0, then what is the amount of power which is get consumed by the inductance? Always it is 0. It means that inductance never consume the active power. That you have to remember. Then with respect to the pure capacitance, what is the relationship with respect to the current and voltage? In case of pure capacitance, current will lead the voltage by 90 degree. Okay, then what happens with respect to the power factor? Cos 90 is how much? It is 0. If the power factor is 0, then what is the power which is to be get consumed by that capacitor? Is 0. Always. Okay, that you have to remember. This derivation with respect to these three is most important for the examination point of view. Is this clear what I explained with respect to the module 1?